In this paper, we embark on a comprehensive exploration of decoding strategies in the context of the pre-trained PaLM-2 large model, particularly focusing on the comparison between standard greedy decoding and alternative decoding paths. Our initial step involved contrasting the conventional greedy decoding approach with those paths where alternative decisions are made at each step, denoted as k greater than O. This comparison revealed a notable trend. Models relying on greedy decoding often bypass the chain of thought, COT, method, choosing instead to tackle problems directly. This inclination likely arises from the model's training, which predominantly features simpler questions, thus skewing its perception of problem complexity. Further investigation into the model's behavior at the initial decoding step with alternative top, k, tokens unveiled that COT paths naturally emerge in many instances. For instance, when examining the GSM-8K question set, a valid COT path became apparent when considering the ninth most likely token. To systematically extract these COT paths, we analyzed the model's logits, identifying paths based on the probability differences between potential decoding routes. Our COT decoding method was thus designed to sift through various decoded paths to pinpoint those embodying a COT approach. Our methodology also entailed selecting the most appropriate decoding path by considering either its length or a normalized probability score, which introduced a preference for longer paths when probabilities were closely matched. Additionally, we refined our approach to identifying answer spans within the model's responses by aligning continuations with specific spans in the decoding path, thereby enhancing our accuracy in tasks requiring mathematical and natural language reasoning. To further enrich the diversity of potential decoding paths, we experimented with branching at later stages of the decoding process. Early branching, particularly at the initial step, was found to significantly increase the variety of paths explored. Lastly, we aggregated answers across all decoding paths using a weighted method, aiming to bolster the stability of our results. This strategy proved effective in maximizing the sum of probability differences across paths, thereby pinpointing the most likely correct answers. Our findings also highlighted the comparative inefficiency of sampling methods in uncovering correct COT paths within a standard question answering format, as sampling often resulted in incorrect final answers, unlike the COT decoding procedure.